Hi, my name is Nilsson and I'll be presenting this paper on behalf of our team from the European Space Agency's Astronaut Center in Cologne, Germany. So first, let's start with some background information. So, as you might have heard, space agencies around the world are currently working on getting people back to the moon by mid-2020s. And unlike the Apollo program from the 60s, the goal now is not simply to put people on the moon and bring them back, but rather to establish a permanent human presence on the moon. And so this is something that will obviously require robust and reliable logistics supply solutions. And so to meet this need, the European Space Agency is currently designing a so-called European Large Logistics Lander, or EL3 for short, which is essentially an autonomous lunar lander capable of delivering cruise supplies to the lunar surface. Now, designing new solutions in this context can be quite hard because of a range of factors, including the reduced gravity and unique lighting conditions on the moon. And so to better deal with these challenges, we at the European Space Agency are currently exploring potential use of virtual reality as a way of simulating the lunar environment and evaluating prospective solutions while they are still at the design stage. So what we did is that we basically selected a relevant 64 square kilometers large area on the moon, and then we fully recreated this area inside virtual reality. In close collaboration with the team responsible for the EL3 development, we then produced a 3D virtual mock-up of a potential EL3 configuration, which basically interactively simulated some of its key features, including things like cargo unloading mechanism or cargo containers, as well as the ladder and antennas. Finally, we invited a group of human spaceflight experts to try out this VR environment for themselves, and we asked them to reflect on these design solutions. And so what we found out was that virtual reality enables reflection on many factors that were previously underexposed, such as, for example, problems related to poor lighting conditions, or the fact that you cannot really see your feet while climbing up a ladder, and things like that. On the other hand, we also found that the limited ability of VR to simulate physical interactions was a bit of a problem, and so in our paper we proposed the use of physical mock-ups or gravity offload systems to compensate for this. So in conclusion, although it might never be feasible to fully recreate the extreme conditions of the moon inside of a lab, we believe that by combining virtual reality with elements of multisensory stimulation, we might actually provide designers with the means to elicit valid and actionable reflections, helping them to develop safer and more effective solutions for future lunar expeditions. Thank you.